Hi, this is Song Chonglan. I'll be presenting effectiveness of virtual reality game in foreign language vocabulary acquisition. Many people experience virtual reality in entertainment form, but there are other uses for it, including in studying cultural heritage, in military, in the arts and industrial sector, and in education. I'd like to focus on 5 main areas. Very little research about VR and education exists. There are many advantages of using VR for educational purposes. VR, for example, could improve the motivation and attention. So the researcher formulated this hypothesis. The participants who use VR score significantly higher on foreign language vocabulary acquisition achievement as compared to those who use the traditional method of foreign language vocabulary acquisition. The 64 participants from Saudi Arabia were non-randomly selected, and the gender was limited to male students ages 12 to 15. So this was a quinzhai experiment. They were equally divided into 2 groups, treatment and control. Each group studied 12 days for 35 to 45 minutes during school day class time with the same teacher. A pre-post test was developed to measure progressive degrees of word knowledge. The treatment group studied in a VR environment game called House of Languages by Samsung Galaxy Smartphone Gear VR. The control group depended on the traditional way. First, reliability. The Chromebox Alpha of 0.899 shows high reliability on vocabulary tests. This would be more convincing if the author provided the raw data, which readers can use to replicate their findings. To what extent do these tests reflect content domain? Responses from the 3 experts and the researcher give 100% agreement. Therefore, the vocabulary test has construct and content validity. Independent samples t-tests are suitable for this research. Table 2. The pre-test mean of the treatment group 58.53 and the control group 59.06 indicate no significant difference between the 2 groups. We can further check the p-value in Table 3. The p-value of 0.795, which is greater than 0.05, shows the equal variance of population. So let's look at the p-value of 0.885, which is greater than 0.05, meaning no initial difference in pre-test scores between 2 groups. In Table 4, the p-value of 0.003 shows the unequal variance of populations for post-test scores. So let's look at the p of 0.013, which is less than 0.05, along with the 95% confidence interval of the difference, meaning a statistically significant difference in post-test scores. To see how effective the VR teaching method is, the author used the eta squared, which may be erroneous. L.W. Rossi points that appropriate effect size measures for ANOVA are eta squared. To compare 2 groups in t-tests, Cohen's D, Glass delta, or Hedges G are appropriate, but not eta squared. Finally, Table 5 shows statistically significant difference between the 2 groups, but I suppose the author has erroneously conducted an independent sample t-test in this table, whereas he should have performed paired sample t-tests to compare pre-test and post-tests of each group separately. In this figure, we can see the mean score of treatment group is higher than that of control group. With steps 1 and 2, we can say the hypothesis is right. To sum up, the participants in a VR environment and those in a traditional condition both made improvement, and the comparison of the past test or using the independent samples test indicates that the treatment group made more progress. Integrating VR technology in teaching EFL is a promising strategy and can be more successful than the traditional learning method for vocabulary acquisition. One of the limitations of this study was the gender was limited to male. It was not fully random sample selected. Some students had additional time experiencing the intervention at uncontrolled times. The 2-week experimental period may not allow for an adequate assessment of the long-term effects of the technology. This is the end of my presentation. Thank you.